Okay, this is Unit 1, Lesson 7, and we're going to be talking about rigid transformations. In our focus question today, what are the effects of rigid transformations on the lengths and angles of a polygon? So when we reflect, translate, or rotate a polygon, what are the effects of the side lengths and the angles? So go ahead and start your warm-up and notes, and you can pause the video while you start that. Okay, let's look at our warm-up. It says for each question the unit is represented by the large tick marks with whole numbers. Find the length of this segment to its nearest 1/8 of a unit. So if I look at these tick marks in here, there are 1, 2, 3, 4, 5, 6, 7, 8. So each of these small tick marks represents 1/8 of a unit, and we have 8 of them together to equal one whole unit. So we have 1, 2, 3, 4 whole units. And then we have 1, 2, 3, 4, 5 eighths of a unit. Okay, number 2 says find the length of this segment to the nearest 1/10 of a unit. So this is 1/10 as a decimal. So let's see, these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of these is 1/10, and that's what we have here, 1/10. So 10 little tick marks make up one hole. So we have one hole, 2, 3, 4 holes. And then I know this is halfway, so that's 5/10, 6, 7 it looks like. So 4 7/10. Okay, so number 3 says estimate the length of this segment to the nearest 1/8 of a unit. So now I'm looking down here and I don't see any small tick marks like there were up here. So I'm going to have to do some estimating. So I know I have 1, 2, 3 holes and then some extra. So I got 3 holes, and I know right in the middle of the holes, if we split them up into 8s, right in the middle would be 4/8. And then this line looks like it's right in the middle of that. So I would go up right between 4/8 and 8/8 would be 6/8. So I would say 3 6/8. Now it says estimate the length of the segment in the prior question to the nearest 1/10 of a unit. So I can do the same strategy. I know that right in the middle is 5/10. So if I go right in the middle of 5/10 and 10/10, that would be 0.75 or 7.5 So I could say 3.75, 3 75/100, 7/10 and 5/100. Or if I were to estimate to the nearest 10th, like it wants me to here, I would have to say either 3.7 or 3.8, I think would work in that situation. Alright, let's go to today's work. Number 1 says translate polygon A, so point P goes to point Q in the image. Write the length of each side in grid units next to the side. Alright, so let's count the grid units. This is 1, 2. Here's 2, 1, 1, 2, 3, 1, 2, 1, 2, 3, 4, 1, and 1. And we're going to translate P to Q. So all I'm going to do, I'm going to trace it here. And now I'm just going to translate this straight over P to Q right there. Now write the length of each side. So this is 2, 2, 1, 1, 4, 2, 3, and 1. So what changed here? Well, the side lengths are exactly the same, right? The corresponding side lengths. So this side right here corresponds with this side right here, and we can see they're each 2 units. This side here right here corresponds with this side here, and we can see that each of them are 4 units. So when we translate a shape, the side lengths stay the same. And of course these angles also didn't change, right? These corresponding angles didn't change either. Okay, let's look at the next one. Oops. It says rotate triangle B 90 degrees clockwise using R as the center of rotation. So this is the point that's not going to move, and we're going to turn this clockwise. We're going to be going that way. Well, clockwise 90 degrees. So this angle here is not going to change, or this point here isn't going to change, and we're going to flip this 90 degrees. So this line right here, if we turn that 90 degrees, it would come out to right there, right? This line here would be going straight up. And then we would just need to connect that. Ooh, that's not very straight. I don't know how straight I can draw on this. Alright, good enough. So now this angle is 90 degrees. This angle here is now right here, and that's 30. This angle here is now up here, and that's 60 degrees. And then this angle here is the 90. So we can see when we rotated this figure, all the angles, the corresponding angles stayed the same, right? This angle right here and this angle right here, both 30 degrees. This angle here and this angle here, both 60 degrees. So the interior angles did not change. So when we rotate a figure, the corresponding angles don't change. Let's look at a reflection. Okay, it says number 3, reflect pentagon C across line L, across this line here, line of reflection. In the image, write the length of each side in grid units next to the side. Okay, so this point here is now going to be, it's going to reflect over this line. Because when we reflect, corresponding points are the same distance from the line of reflection. So this point here is going to be here. This point right here is 1, 2, 3, and a little less than a half. So we're going to go 1, 2, 3, a little less than a half. And then this point here is 1, 2, 3, and just a little bit more than 3. So I'm going to go 1, 2, 3, and about the same distance. And then this point, that's going to be along this line, 1, 2, 3, 4, about 4.5, and a tiny bit up. So 1, 2, 3, 4.5, and just a little bit up. So about right there. Alright, so let's make our shape here. So that looks pretty good. So in the image, right, the length of each side in grid units next to the side. So this I know is 3, and that's 3. These are going to be the hard ones, right? Because we have to estimate, just like we did in our warm-up today. We go 1, 2, and just a little bit less than a half. So I'm just going to say that's 2 and 3/8. We can measure it. We'll say, since we have, let's see, what's this? Centimeters? No, those are, well, we don't know. But these are in eighths. So if we say this is 2 and 3/8, let's see how close I was. Oops. So this is 2 and, that's about 2 and 4/8. Is that the same length? No, it's a little bit, should be a little bit smaller. There we go. That's closer. Okay, so we're going to say 2 and 3/8. And we're going to measure this one. It's about 2 and 2 and 2 and 2/8, or 2 and 1/4. Okay. This one. About 1.5. 1 and 1/2. And this one's going to be a little bit more than 2, right? Two and, what is that? Is that right at 2? That can't be right at 2. Oh, these are a little bit bigger than the square, so looks like we're about 1 and, no, it's right at 2. 2 on the tape measure there. So that means, all right, angles. So if this is 90 degrees here, this is 90. This one here is 150, so that means this one here is also 150. This one here is 90. That's 120. So that's 120, and this one here is 90. All right. So we can see the side lengths stay the same. and the angles, corresponding angles, stay the same. So the corresponding side lengths stay the same, corresponding angles also stay the same. Alright, so let's take some notes. So when you perform a rigid transformation, either a rotation, a reflection, or a translation, the corresponding side lengths are congruent, meaning they stay the same length, and the corresponding angles are also congruent. They stay the same